Welcome, everyone. Welcome to this another episode of Excellence Continuous Intelligence Podcast. In this podcast, we will explore the transformative power of AI in manufacturing. We'll also dive into some of the most pressing challenges on the shop floor today. Things like unplanned downtime, quality control issues, and operational inefficiencies. But think about this. What if we could predict these problems even before they happen? With AI-driven predictive metrics, manufacturers can actually move from reactive firefighting to proactive problem solving. I'm Anand Natarajan, your host, and joining us today is Osvaldo Santiago, who's an experienced operations supervisor, a controller, and who also understands the real pain points of the shop floor and how AI can really drive tangible improvements. So let's explore how data-driven insights are shaping the future of manufacturing. So welcome to this podcast, Osvaldo. To kick things off, can you provide some of your valuable insight on the current state of manufacturing operations and describe some of the biggest pain points you see on the shop floor today?
Sure. So obviously, first of all, thank you for having me. And I'm not a data expert or an AI expert. However, I have over 20 years of high speed, high volume manufacturing experience with three Fortune 100 companies. So I have seen a thing or two. Related to pain points, obviously, the one thing that affects any manufacturing site would be unplanned downtime. That's is the Achilles heel, if you will, in manufacturing. Perhaps not having the right technical knowledge with the staff to do proper troubleshooting and get the equipment up and running as quickly as they can, or having good escalation systems that if they are not making progress, they can automatically then escalate to the next level for help. And then having data that is actionable data so that a database decision making takes place while you're doing the repairs or just in general as you interact with the equipment on a day-to-day
Got you.
basis.
So, talking about downtime on the shop floor, right? It's quite a big problem because it does cause, at the end of the day, bottom line issues, right? What are the most common causes of downtime, in your viewpoint, in the manufacturing operations today?
So, obviously depends on the type of equipment that you have and the complexity of that equipment. I would say that, maintenance and repairs are the number one, repairs being the number one cause for downtime. So having breakdowns, as we just talked about. And, again, just having troubleshooting. Troubleshooting is key because it could be the difference between having that piece of equipment up and running within 30 minutes or it could be 30 days, right? You never know if you don't have the right troubleshooting knowledge and expertise with your staff. If they're not using the right data to be able to get to what is root cause. I've seen troubleshooting by replacing components, which it gets very expensive and many times it doesn't get to the heart of the problem. Um, it could also be another downtime driver could also be, or a cost of downtime could be in process inspections that may take that technician away from the equipment. And now they're not monitoring the equipment. They're perhaps doing testing, destructive testing, whatever it is. So those are, I would say, the majors, repairs
Got
being
you.
the number one.
Now, to alleviate some of these problems, I know companies come up with some kind of a preventive maintenance on a regular cadence, right? So, how do you currently handle maintenance, and what are the challenges that arise with the traditional methods of preventive maintenance?
So my experience has been that companies are either doing too much maintenance or not enough. And I know that sometimes, that doesn't sound right when you say too much maintenance, but at times I have seen that where you have a frequency for inspection of components and you have been checking the same component for 3 years and it hasn't failed, then why perform that inspection? Perhaps that the frequency for that inspection is not optimal. So not having the right maintenance frequency is one. Not doing predictive maintenance. There are so many opportunities with new predictive maintenance tools that you could employ to help you have a good predictive maintenance program. And you have to periodically revisit your program and make the right edits or the right improvements so that you optimize your program.
Got you. Okay. Interesting. So, in terms of this maintenance, and we touched upon data a little bit in the beginning, what role does data collection and analysis play in your day-to-day operations? Are there gaps that you see?
Yeah, so data is key. I used to work for a manager that used to say, "In God we trust, and everyone else brings in data." So I subscribe to that. Data is key. Having a good machine data acquisition system is imperative. Also, is collecting the right data, right, so that it can aid the technicians in troubleshooting and the decision making. And then if you're collecting the right data, is what to do with the data. A lot of the times, we collect so much data that it can be overwhelming. And technicians don't really have the time to be sifting through that data to be making decisions in terms of how to optimize their piece of equipment. So with AI, again, with my limited knowledge, I know that there are new tools such as, let's say, a version of an industrial version of ChatGPT that you could use as an input device to interact with the equipment and say, for instance, are my servos optimized? Why is my pusher running slow? Why is my shuttle jamming? Why is my module, the throughput not optimal? And the system can do some analysis and let you know. So it's really exciting in terms of the opportunities.
Understood. And despite all this, all the preventive maintenance that every technician tries to do, there does occur unplanned downtime. So, what are the ramifications of such unplanned downtime? Impact on productivity, costs, overall efficiency. How does that play out, Osvaldo?
So I was told once that it's been calculated that on the average, unplanned downtime is 65% more expensive to a business than planned downtime. And think about it, it makes all kinds of sense, right? You plan a repair, so you have the components available, you have the technicians with the proper know-how available to do the repair. Perhaps a component needs to be calibrated, so it's already calibrated, ready to go. You stage everything there next to the equipment. You cycle stop the equipment. You start the clock. The right people jump in and make the repair. You know, reset and start. As opposed to something happens and is unplanned, who knows what can happen? A lot of the times, the components are kept at an offsite warehouse where now you need to call for those components because depending on what it is, I'm thinking of a large servo, perhaps a robot that you keep offsite. Now the equipment has to be brought to the site. You have to perhaps calibrate it. Perhaps the person with the right knowledge is not available to make the repair. It can really be a nightmare. So planned downtime
I
is the way to
totally
go.
agree. Yeah, it's some interesting scenarios you brought there too, and you had touched upon the potential of AI in a couple of questions before. So let's kind of delve into some of that and look at where you see the biggest opportunities for AI to make an impact in manufacturing operations.
Yeah, so as I indicated, obviously I'm not an AI expert, and I'm sure that I'm just my knowledge of it is just like is scratching the surface. But I envision that you could have machine parameters being analyzed passively in the background, and the system can be giving you feedback via an HMI to perhaps making recommendations to the technician regarding optimization opportunities. Or in some instances, I'm sure that it can even be set up so that the system itself can make those corrections so that there is no human intervention. I think that the opportunities are limitless. We're just getting started.
Sounds really promising. Now, with AI, I'm assuming there are some common failure patterns or inefficiencies that AI could help detect before they cause major issues. Is that your assessment too, Osvaldo?
Absolutely, absolutely. As I indicated, let's say you can have the system analyzing a certain signature to
Uh-huh.
let's say a servo motor. So in the background, passively, it can be analyzing that signature, and it can predict a failure. If it notices that there is binding, a component could be running hot, or there's so many things that it can be analyzing in the background. It can give you notification that perhaps you need to schedule this component for a swap out or a repair as soon as possible. Wouldn't that be ideal if we were running like that, as opposed to, I'm the technician and I'm sitting there just waiting for something to break so that I can fix it. That's not the way you want to operate. Again, I think that in some instances, in that the system is making adjustments within validated parameters, just parameters. It can do it for you before a breakdown happens. It can make the right adjustments passively in the back
Well,
in the
that will be
background.
really a nice streamlined way to kind of handle some of this proactively here. And
Sure.
we've
Absolutely.
talked about preventive maintenance or predictive maintenance on the line. Can AI, in your assessment, also help with things like quality control, defect detection on the production line?
Sure. So, I think in this case would be, perhaps by analyzing inspection data points. So most of the modern manufacturing equipment has like inline inspection devices. So the system could be analyzing the results that you're getting, and it could help in keeping your process centered. So you could make the right adjustments to keep, let's say you have a device that's applying a seal. So you need certain pounds of pressure, and that's being, and the pressure may be degrading a little bit. So it could make the right adjustments to keeping that pressure consistent, or perhaps the seal temperature consistent. So it could be keeping that process center before you start making non-conformance product, before you start producing product that it's not meeting conformance. So I think that it would be invaluable
I
for
agree. And
quality
all of the
control.
cost savings, the cost avoidance with all of these defective products from actually being either built or, circulated, etc. So definitely. Now,
Absolutely.
you've seen in your work, you've seen all kinds of scenarios. You've worked on different production lines. You've probably seen a lot of challenges. Now, with the potential of AI and the promise of AI, what do you think are the biggest barriers to AI adoption on the shop floor today?
Well, I would say, as I see it, is not knowing enough about AI capabilities. So a lack of understanding, I say, would be number one. Because I talk to a lot of people that they don't really have the awareness and the understanding of what AI can do. A lot of people think that is the flavor of the month. So they think, we don't need it. So again, I think it's not understanding the benefits. And I think I've heard from others that, thinking it's too expensive to implement. So cost.
And then I know you've also come from a regulatory compliance kind of world. Are there any regulatory or compliance challenges relating to the implementation of an AI, system in manufacturing?
Sure. Obviously, if you work in a regulated environment, you might have some kind of validation that needs to take place. So your quality and compliance group may have some requirements that you need to adhere to or you need to meet before AI could be implemented.
Got you. Yeah,
But
yeah.
it's very doable.
It's interesting. We've covered a few areas here, but there's one clear lesson here. It's like waiting for machines to break down before fixing them is like waiting for your car to run out of gas before stopping at a station, which is not the most best strategy, right?
Exactly.
So I think AI
Exactly.
driven predictive metrics, it's not just a futuristic concept, right? I think it's a game changer for manufacturing operations. And I think by anticipating machine failures and optimizing workflows and enhancing the quality control, I think AI can really transform the shop floor from reactive to proactive, and from uncertain kind of scenarios to more kind of precise response, right? Problems or challenges. So the key takeaway, I think, Osvaldo, for me is, AI isn't here to just replace human expertise. It's actually here to empower and provide the right insights at the right time to drive efficiency and reduce downtime, improve overall productivity. That's what I think AI's promise holds.
Absolutely. Absolutely. I think The same way that you have robots working side by side with humans as cobots, it's AI is providing the same level of service, right? It's taking a big task, as in analyzing all the data, every parameter on that piece of equipment, and letting you know as a technician running that piece of equipment that perhaps there are some opportunities to optimize it, optimize your process so that you improve your throughput, or the components run better, or there's a lot of opportunities.
This has been truly eye opening. Thanks for your insights, Osvaldo, and thank you for joining us on this deep dive into this future of manufacturing.
Thank you
Thanks,
for having
Osvaldo.
me.
So
Appreciate
until
it.
next time, let's keep pushing the boundaries of innovation then.
Take care.